All right, in problem number 5 on page 2 of our volume and surface area packet, we're asked to find the surface area of the prism. So number 5 is a triangular prism. And I know that because I can see that there's a triangle here on the front that's parallel to the triangle on the back. And that each of the sides, remember, in a prism, all of the sides are rectangles. So this is a rectangle, this is a rectangle, and this is a rectangle. So I have 3 rectangles and I have 2 triangles. So in order to find the surface area of the prism, the total surface area, I want to add up the areas of all of those 5 faces. We have a formula over here on the left, LA. Remember, lateral area was the area of the sides of the figure, and the 2B was the area of the bases, 2 times the area of the base. So since I have 2 bases, that's where the area of the bases would come from. And then the HP, this would be the height of the prism. Notice that this is 3. So I'm getting a width of 3 here for both this face and this face here and this face down here. So that's really the height between the bases. And then if I multiply it by the perimeter of the base, I'd actually be getting the side, the area of this side, the area of this side, and the area of the bottom. But I think that these formulas are hard to remember, so I'm going to think about it in a different way. I'm just going to add up the area of all of those faces. So we do know that we have 2 triangles. So we're going to find 2 times the area of the triangles. Plus, we're going to have the area of a rectangle, plus the area of another rectangle, plus the area of another rectangle. So we have 5 faces to find. 2, 3, 4, 5. And these rectangles are not all the same dimensions. So to find the area of the triangles, there's 2 of them. And we know that that's 1/2 base times height for the triangle. And this would be base times height for this rectangle. We could call that rectangle number 1. And this would be base times height for rectangle number 2. And this would be base times height for rectangle number 3. So we're going to find all of those now. The 2 and the 1/2, 2 times 1/2 is just going to be 1, so we don't even need to worry about that. We're just going to do the base of the triangle times the height. So I can see that the base of the triangle is 12, which is the same length as this one right here in the back. And to find the height, I have to look back there at the back and look for that right angle symbol. And I see it right here, so I know that this is the height because heights and bases are perpendicular to each other. So my base is 12 kilometers and my height is 4.1 kilometers. And I'm going to write the units underneath again just so that I don't run out of room. And for this first rectangle over here, I'm going to look at the slanted one on the left-hand side. I can see that it has a height of 5 and a depth of 3 kilometers. So that's 5 kilometers times 3 kilometers. And then I'm going to move to this slanted one here on the top. And I can see that that has a width of 3 and a length of 10. So that would be 3 kilometers. Oops. And I'll try and erase that. 3 kilometers. Didn't do a very good job. 3 kilometers times 10 kilometers. And then for my last one, which is the bottom, I've got 12 kilometers. And remember, the depth of that was 3. And now I'm going to sum this up. 12 times 4.1, that's 48 plus 1.2, or 49.2 kilometers, square kilometers. 5 times 3 is 15 square kilometers. 3 times 10 is 30 square kilometers, and 12 times 3 is 36 square kilometers. And that should come up to be a total of 130.2 square kilometers is my total surface area.